Hello, my dear friends. My name is Andrei Lee, also known as Andrei Lee PhD. We have an interesting task. We have to analyze and maybe contribute to PySyft, as I guess from the scholarship. I have prepared for you this nice tutorial that will guide you through the source code of PySyft. So, what is PySyft? PySyft is a product of the company called OpenMind, and this is the website of this company. You can see this is very nice looking website, like a $1 billion project. But we will see whether it's will get this $1 billion. I don't know, but let's hope so. Here we have it's a framework, as you know, for privacy preserving deep learning. Very interesting project and very promising, because we can make artificial general intelligence that works on the open mind, and maybe it's not a very far future. I think if it's PySyft and open mind, it is possible to do just like this or that. Anyway, what I want to say you. It's what is this? It's as I said, privacy preserving framework. What it means is that using different technologies like federated learning, differential privacy, multi-party computation, homomorphic encryption, and there are additional things like consensus governance, threshold governance. We can make artificial general intelligence that is keeping your data private. So very interesting, very involving, and I was interested in this. And when I first saw the opportunity at Udacity that I can get the scholarship, first of all I thought about one big model that is working on distributed computers, and it's like doing social good, doing something good for people, like forecasting different events, maybe different I don't know, social conflicts or weather forecast to show us where might be some storms or kind of a bad weather or any other things, solving human problems, doing something good for not only for profit, but profit is not bad, but for people, for society, for the countries, for the governments, for the all the people in the world. So this is a very open project, and it's kind of touched my heart. So let's move to what is this all about. So what is the federated learning? The main three components of this framework is federated learning, differential privacy, multi-party computation, and that's it. It's multi-party computation kind of include homomorphic encryption. It's all together. So federated learning is when we are doing computation on different computers. So we are not training on the central server. We are training on the computers of the users. Differential privacy, it's a definition that was brought to us by Cynthia Dwork. She has a nice formula that is kind of maybe not so easy to get, but when you get it, like even partially, idea is great. I'm not sure about the bright future of differential privacy, but maybe I'm wrong and it will be the future. And multi-party computation. It's encrypted information. You can do with homomorphic encryption. You can do computations on encrypted data. So all these frameworks are good. So what we are going to use today, we are going to use a very perfect software that I have selected for you. It's called Understand. This is the interface of the software, and we can go to the website of Sky Tools. This is their company that wrote this very beautiful piece of software. And we can see, like, we can download free trial, and you can definitely buy it, but it's pretty pricey. So it's like $995 or something like this. Yes, $995. So it's a pricey thing, but trial for me is enough to get the idea. For 15 days, I think that they're giving me. It's enough to some kind of have a short look on the PySyft. And to say the truth, I have not analyzed it deeply. We are going to analyze it together, so, and understand what it is all about. So let me tell you about different products that you can analyze big code, and I will tell you like a lot of pluses why you have to use this software or another software like source analysis software. And there are different, you can go to GitHub and try to get like try to look at the Sift, and then for example, look at what is it, generic, and then we have object storage. But the way it is used, there's no option to click on the class and see how it's used. You can like push control button and click on object storage, and it finally shows you where it's referenced, how it's used, where it's instantiated, and other things. So it's very nice features that understand have and Source Insight have. It's also a very nice piece of software that I think less expensive, but I'm not going to promote you these tools. I just let you know that these tools are available. And SourceTrail, which is free, but it doesn't have so much power over traveling through the code. With Source Insight, you can travel through the code easily. So 3 choices: Understand, Source Insight, and SourceTrail. So there is a option to do kind of a code analysis and visualization with Doxygen, something like this, and it's also very useful software, but I have not tried it. So let's move to the examples. So we have a code. Here's basic operations that we can perform, and basic operations are like what is this? Like we are installing Sift. It's installed through the pip. Pip installs Sift, and it's installed. There are some problems with installation, but I will not cover it here. Like TAFE encrypted is using not secure randomness and other things, but I think you will solve it. So here we are like using TorchHook. We are using library PyTorch, product of Facebook, and we're using this TorchHook. And we kind of what we are doing with TorchHook, we are adding in methods and functions to the Torch. So for example, this is the usual functions of Torch, and send is like this hooked function that can send you your data to this virtual worker. So virtual worker is like not a real like WebSocket connection, but it's a virtual worker. So it's on your computer, but it's very good for experimenting and other things. So you can use it. You can send tensors to Bob, and Bob will be happy to receive these tensors and make computations for you. So this is a really nice idea, and you can make basic operations with this. And you see like objects, different tensors. They have this number. This number, I don't want to be like explaining everything, but this is a random number. It's not hash, but it's a random number, also a good thing. So this is the pointer, and this is the tensor. So we can do different operations, and basics are like send, location. You can see where this data for particular tensor is located. You can see that it's located on virtual worker with ID Bob and tensors in tensors. And you can do many operations, and that's it. So pretty easy. You can do many things, and then you can do deep learning. So let's move like a little bit forward. What we do have available? Federated learning, example of federated learning on NIS data. So very nice and very inspiring to have this kind of examples from OpenMind for us to test and see what it can do. You can see that it can do deep learning, federated learning. It's not encrypted data, it's just sending it, but in other examples you can see that it can do encrypted computations on encrypted data using multi-party copying computation and homomorphic encryption. You can see that we first have to hook Torch and make virtual workers, and then here are the arguments, and then we load in data, creating the model, creating train function, creating test function, and then we start it, and it's trained on the Bob and Alice. So why Bob and why Alice? Alice and Bob are famous persons in cryptography. What they did? Nothing, just we used it to refer to like two parties that want to use encryption to communicate with each other or do computations like this. So Alice and Bob are mythical people that we are using, and that's it. So basic computations, and PySyft supports also Keras. So it supports Keras and PyTorch, and as you can see here, we are using Keras. Support, I would say, PyTorch, TensorFlow, and as TensorFlow is like is TensorFlow 2.0 becoming more like a Keras, or Keras becoming more like a TensorFlow, I don't know, but it's how it's used. Don't look at this. I did a little experimenting. Everything's working fine. So here we use TFE workers, and here in TensorFlow Keras hook, there are three main methods available: model, share, and shutdown, as I remember. So we can see that we have share, model serve, and shutdown workers. So this is our three main methods available for us. So let's move forward to understand. You can see that it can do many things. So when we send, we just send. When we share, as I understand it, we're using multi-party computations and homomorphic encryptions to do computations. So it's encrypted computations. So let's move forward to understand. So this is the nice software. As I see, I use trial license. And what should we do? We go to File, New, Project. And where is the source directory? Add the directory, ADD directory. And we go to Documents, Udacity, PySyft. And we will create a folder called Understand. And in this folder we put projects files. So there are three project files, different kind of metadata about the project, and we move forward. Project summary. Okay, configure advanced settings. No. Create project. Okay, we have created project, and we have to add files to their project. So I used a previous version of Understand, and to say the truth, I don't know where to analyze change files, configure the project. Okay, it should use Python, because PySyft is Python, everything is Python, and folder that's using to analyze files should be another one. So let me make another folder. Okay, override file type endings. No, it's not this. Open import just like this. Okay, so let's create a project in a directory where we have our our where is your source code? It's asking where is the source code. So perfect. My source code is in Swift, in PySyft. In this folder is used for build process and different examples, documentations and other things. We need Swift, and here we have our projects. 65 files, Python. Okay, create project, and boom, we have it. It's analyzing all this structure, and we can see that we have like all overall structure of our code here. And what's nice, we can click here and we can see the code. And if we push Control and like func to plan, and we can move there. If you want to see where it's referred to, you can put here, click it, and from here we can see references where it is used. So it's very easy to travel through the code using this software. Very easy. You will understand me. But first of all, I will set up my my usual environment. So let's move analysis log. So no bookmarks. We don't need bookmarks, but contextual information, dependency browser, entity filter, entity locator, information browser, if you have it, previewer, project browser, we have it, scope list. Okay, in Windows Selector we have it. So where is this all? Nothing appeared. Okay, what do I need particularly I need contextual information, and that's it. So I think I can see it right now. No, it's another one. Let's dependency browser. No, not this. Entity locator. Okay. Information browser. So there should be a second window, but I think we can live without it. Or we can, we have everything here. Right, perfect. Oh, it's working. Finally, it's working. So I'll move it over here. To say the truth, I'm not really used to this new version. I use previous version, and we can move here all the necessary settings that we need. So it's like, for example, if you move to init, and then we click virtual grid, and it's showing us code. If we move here, it's moving to this like particular code. Very easy, very simple, very useful. So you will see that this is a very great product. I'm not advertising you, but I just love this product. So let's start analyzing. So we have init, we have federated, where it's our logic about federated learning, frameworks, it's a hooks and other classes and method that implements this hook. Generic, it's a generic storage for our objects that we send to the remote workers. Serde, it's a serialization, deserialization. So when we send to remote workers, we first do the process of serializing it, compressing it, and uncompressing it, deserializing it. And this is what the Serde do, and workers. So we have different workers here. You can see it's perfectly clear. And workers are your kind of workers, virtual workers, or remote workers like that use a network to communicate with the framework. So perfect, and we have set up everything, and let's move to the source code. So I will collapse all these things, generic server workers, and let's move to init. So here we are importing all the different parts of the PySyft, and we importing frameworks, workers, codes, federated, Keras hook, TorchHook that we need to add additional functionality to PyTorch or Keras, and virtual grid, it's for searching through different workers, plan to execute set of operations in on remote workers. Found to plan, it's more particular implementations of plan. TFI workers that we use for Keras implementation, virtual working, and different kind of tensors that we use in PyTorch. In PyTorch implementation is much more complicated and much more thoughtful than Keras. Keras is very simple. It's used on TTF encrypted, and that's it. So and we just add additional methods and functions, and that's working. Third, serialization, import federated dataset, federated data loader, base dataset, and we define all that will going to be available through their when we have like Jupyter notebook, and we have loaded Swift, and we type Swift point, so it shows us this kind of things. Here we assign variables and ID provider. It should be in generic. It's used. So for example, you can click ID provider and it should show you the class. Okay, it's ID provider. This is ID provider. It provides you ID for your data. So it's creating these IDs, and here we have a nice function that is not related particularly to the functioning of the Swift framework, but what it's doing, it's creating Sandbox. So developers decided to make this function available for you to very quickly create all these different participants of the computations, like Alice, Bob, Theo, Andy, Jason, John. I'm not sure about Theo and Jason and John, but Alice and Bob for sure are the main characters in cryptography. So all examples in cryptography are made through the Alice and Bob. So what it's doing, it's checking whether we have Torch or TH, how we imported that, and then we loading data sets and creating virtual workers and loading the data, as I said, and instantiating virtual grid. So this is the create sandbox. It's creating sandbox as you know it. So just a sandbox where you can experiment. So when you run this function like Swift create sandbox, it creates Bob, Theo, Alice, Andy, Jason, and John, all ready to work and do computations for you. So perfect. So let's move to another one. So let's see what the code is. So this different kind of commands, message types, command, object, and this is used internally. Different kind of exceptions. So I can see we have different kinds of exceptions. Poor torch tensor found error, remote object found error, invalid tensor for remote, and different kind of others. You can see shortly what is this all code is all about looking here. So I can see Swift exceptions, and all these exceptions that are going to be listed here shortly are provided here. So very beautiful thing. So as you see, they inherit from base exception and from exception, inherit from exception, And what is doing, what is this for? It's exceptions that PyTorch raises when the problem arises somewhere in the code. So if we have a grid, it's a virtual grid. It has ability to add to search for tags in the workers. So you can assign a tag. As you can see, an example in OpenMind PySyft repository. You can assign tags like ID Bob Home, Alice like I don't know New York, and you can search through the virtual grid these workers very easily. So it's very simple. So when we hook two things. It's Keras and Torch. And let's move to more general or generic functionality before we move forward. So what is this all about? Federated init py plan, function plan, method plan. It's all like class plan that we can see if I push control button and click plan. It inherits from object storage. So object storage, it's main object that we use in PySyft. So if I'm if I'm not correct somewhere, please correct me. Like post a message and on YouTube channel and on this particular video and say, yeah, you're not correct. I know what is this all about, and you can tell me this, and I will be very happy if you give me feedback. So that's it. So plan, what is this plan for? Make plan, let's see general what the class plan is. Plan store is a sequence of torch operations just like a function. A plan is intended to store a sequence of torch operations, and that's it. It's what you need to understand. It's storing a sequence of torch operations. But it allows to send it to remote workers and to keep reference on it. This way, to compute remotely the sequence of operation on some remote input reference through the pointers, instead of sending multiple messages, and to send single message with the reference of the plan of the pointers. So it's kind of a very good thing to decrease the traffic from one node, from one worker to another, or from the central central worker to remote workers. And this is how we see it. We can raise it here, and we can see that you have different methods available, like send, get, copy, build, and other things. So let's I should have covered frameworks. It's hooks. So what are the hooks? They provide additional functionality to the traditional PyTorch on Keras operations like send, share, and other things. So generic, what is all about? It's ID provider and object storage. ID provider provides ID. As you can see, it creates random number and generates random number. It's how it's providing IDs. And this is the whole class that implements different methods. Pop, set next IDs, record IDs, and different kind of other things. You can scroll through and see the particular implementations. So object storage is the main object that we have to cover. As you can see, it has different methods: register objects, get objects, set object, remove object, the register object from registry, and this is all very perfect. You can see this is the base object for all Swift operations. Serialization, deserialization are very simple. So what is it doing? Here I saw nice manual what it is doing, but it's not here. Sure, there. So what is it doing? When it's sending, it simplify, converts PyTorch objects to simple pickle objects, serialize it, compress, send, decompress, deserialize, detail, convert Sandbox to PyTorch objects. So in 2 words, it's converting it before sending to binary, compresses it, and and then decompress it and converts back to PyTorch tensor. So it's sent through the network. So this is the torch thread implementations, and we have workers, different workers. I think the base is the abstract worker that inherit from ABC. ABC is a library, Python library providing abstract classes, and you can inherit from these classes to make a particular implementation. So base worker, this is very important. We inherit from abstract worker and object storage, and implements the following methods. Clear objects, as you can see, as you can remember from their, if you already studied PySyft library, there are examples when you can clear objects, remove broken from the registry, send it, and different kind of particular implementations of maybe some additional functionality that allows it. The fee worker is used for keras operations, and virtual worker is our usual friend that we instantiate to do like virtual operations, virtual computations on our the real computations on our virtual workers. So it's very, 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 very nice. WebSocket client, it's for networking. Workers. I have not tried, but I will try it for sure. As you can see, it provides different functionality. There is a WebSocket client and WebSocket server. So names are telling us everything about it. It's a WebSocket that provides networking. I think it's used for real networking workers. So you use WebSocket client and WebSocket server and connect it, and it's all created. So let's move to particular frameworks. So when we init it, we import keras hook and TorchHook. And as you remember from here, for example, for keras we use keras hook and AF keras. This is a part from here. We use keras. This is init, keras and torch. They're available, and we use hooks for torch and for keras. So this is a more complex thing. I'm usually getting. I will briefly explain what is this all about, but we will focus more on keras implementation on keras hook. So let's move on. Init. So this is a pretty straightforward. We have a keras hook that is available to us when we type Swift. Let me see. Swift C is pretty important. Swift as C dot TorchHook or keras hook. So for a particular implementation is keras hook, and it's importing model and layers and hook itself from the hook. So as we can see, it's importing this thing. What is this doing? So it's getting like a library, as you can see here, keras hook, TF keras. So we are importing keras, and self keras is keras, and if it has attribute hooked, then if it doesn't have attributes hook, we call functions hook layers and hook sequential, and put hooked true, underscore hooked true. So if you import second time, this already happened, hooked true already true, and it's moving forward. It doesn't allow to import second time and hook second time this library. So what is doing? Hook layers. It's hooking layers, and hook sequential, hooking sequential. What does this mean? So if you look at the filter layers over here, returns all the layers type in the model. So what is this doing? Is this checking if TensorFlow encrypted? It's a library that Swift relies on. If these layers from keras are supported by TF encrypted, then we add constructor to this. So what is this doing? It's overriding init method and making it that it's available to the users of Swift. And then we have hook sequential. So as you know, keras have like keras.sequential, and you can implement sequential logic here. And what it's doing, it's set attribute is setting the attribute, but what it's really doing, it's creating a method share, serve, and shut down workers. So it's kind of adding, augmenting, allow keras library with all these three methods: share, serve, and shut down workers. So this is pretty simple. And if you look here, this is our init, and this is our constructor. Add the constructor registration that we are calling from hook. As you can see, add the constructor registrations, calling this. First of all, it's calling filters, and we are understanding what TensorFlow encrypted and keras have shared layers that are supported, and then it adds constructors, it overrides init, and it defines its logic. And then we hook sequential. In hook sequential, we are providing share. If you click here, this is a file constructor py. No, it's a sequential py. Correct, it's here sequential py. As you can see here, it's a C framework, keras, model, sequential py. And what it's doing, it's adding share method that allows multi-party computations on encrypted data. Here is a serve. It's for putting our model in production on our remote workers, or I don't know, somewhere else. And shutdown workers, configure TFE. So let's move forward and understand what is this doing. For example, share. If we move here and bring it to the main screen, okay, we have it here. It's a sequential py, as I think. Right, it's sequential py. And if you move here, so for example, if you are calling share, it's calling configure TFE. It's configuring TensorFlow encrypted. Configure TFE is calling what is this calling? It's configuring TFE, and then we rebuild TFE model. So if you click here, it's rebuilds plaintext keras model as a TF encrypted keras model. So it's converting keras model to TF encrypted that we can use this encrypted computations on. So very simple. And then in this rebuild model, we are calling instantiate TFE layers. Let me bring it here, and you can click here, instantiate TFE layers. And it's this is another function. So one function calling another function, and another function calling another function, and these functions are share, that's calling configure TFE. Then it moves forward and then call rebuild TFE model, and then calls instantiate TFE layer. So this is the doing logic to have our layers encrypted. So in here is the get layers type, trim parameters if they are not supported. So very simple. So this is all. We considered all parts of keras implementations and keras hook implementation. And let's have a look at another thing. What we are going to look for, we are going to look on TorchHook. So TorchHook is more complicated. As you can see, it's not using TF encrypted as far as I understand it. So it's implementing, for example, if you look at the crypto and we go to secure RNN, here's the paper, secure RNN paper. I can spin it up. So for example, we can put it over here. And this is a paper. So you can read through this paper, and this paper is implemented for TensorFlow encrypted, and TorchHook is not using TensorFlow encrypted. It implements this paper itself. So TorchHook is more complicated and really worth looking to. At the moment I'm studying, but we can see that we have differential privacy, where we calculate path. We have federated, different data loaders, dataset, utils. We have hook itself. We have pointers, as you can remember from the examples on OpenMind website. It implements different tensors, callable tensors, callable pointer that we can call, object pointer, object wrapper, point tensor, and different kind of functionality. So, and this is a basic tensor decorators, interpreters that we can use, and this is more involved implementation. If you look at init.py, it imports different libraries, TorchHook, from hook imports TorchHook. For example, where is the TorchHook? That's it. So this is a TorchHook. It also augment functionality to the traditional PyTorch library using torch attributes. Let me show you where it is. For example, this is the torch attributes. This is additional parameters that we hook to basic PyTorch functionality. And you can have a look at this. I think for beginners introduction to the PySyft, it's enough. So you can have a look at this more closely. My name is Andrew Lee. I'm very happy. I was very happy, and I'm very happy to present to you this nice video. I hope you enjoy it, and stay with me. And have a nice day. Bye bye.